Last time we looked at all that hot, moist air rising near the equator, where all the water gets squeezed out as it goes into the cold realm above. What happens to that air after it rains is the story of where the Earth's deserts come from. We're going to take a look at that now.
Let's pick up where we left off last time. We had seen that the rising hot, moist air along and near the equator encountered the very cold air at a high altitude, and most of the moisture was squeezed out as heavy rain, forming that rain band called the Intertropical Convergence Zone, or ITCZ. As we've said, it is very high up in the atmosphere above where the large jets fly. That air now spreads out towards the north and south, and as it travels it gets colder and colder, squeezing its remaining moisture out as it goes, giving the rain which sustain the tropics. I found my favorite graphic on this subject on Arizona State University's Ask a Biologist website. It shows that both the tropics and the world deserts are the natural product of the ITCZ. Let's take one part of the circulation at a time. First, as we've seen, the sun's energy creates hot and wet air near the equator. It rises strongly into the colder altitudes, squeezing most of the moisture out of the air and causing those major storms along the line we now know as the Intertropical Convergence Zone. The second leg of the circulation brings the lofted air thousands of miles north and south of the equator. In the process, the rest of its moisture is dropped as rain as it continues to cool up high. This produces the lush, wet band we know as the tropics. The third leg finds that dry, cold air descending because it is more dense. But the higher atmospheric pressures near the surface heat that air, making it even more able to hold moisture. It is super dry as it hits the surface. If it is not over the oceans where it descends, it will suck all the moisture it can find out of the air, so few clouds can form and moisture is evaporated out of the ground. We're looking at the creation of the world's great deserts. The final leg, the passage of that air back over the surface to replace the air rising in the ITCZ, is a wild story in its own right, and we will take that up another time. Here's a video from Earth Null School. I've selected the aqua color for how much moisture is in the atmosphere, which could actually rain. Obviously there's plenty near the equator, but go north or south about a sixth to a third of the way to the pole, and it's a lot drier. That's often going to play out by causing deserts. What is our nugget this time? We are now seeing the sun's energy being moved thousands of miles away from the equator by the heating, cooling, squeezing, and circulation of air and moisture. It's like an engine, and it is creating and sustaining both the tropics and the world's deserts. Amazing, and we're nowhere near the poles yet. As you chew on this morsel, feel free to like, subscribe, or comment on the videos. We all need to know how the climate actually works. Thanks.